Okay, Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera. So in this video, we will discuss about how to describe the hybridization in barium chloride. Actually, we already discussed this in our tutorial class, but I repeat it again in a form of video so that if you miss the class or you miss any part and you want to repeat it back, then you can watch this video. Alright, so how to describe the hybridization in barium chloride? The first thing, which is the most important thing, is you have to draw a correct Lewis structure. So we have beryllium that contain 2 electron and 2 chlorine that contain 14 electron. In total is 16 electron. So we have beryllium as a central atom and 2 chlorine. So we already use 4 and we have another 12 electron extra, and we distribute the electron to the terminal atom. So this is the first step that you have to run or you have to do when you want to describe the hybridization. Okay, the second step is you have to identify how many sigma bond around the central atom. So this is the tip to identify the sigma or the pi bond. If you have a single bond, it's only have a sigma bond. If you have a double bond, you will have 1 sigma, 1 pi. If you have a triple bond, 1 sigma, 2 pi. So please remember this. So in this case, we only have a single bond. So we have 1 sigma bond, 1 sigma bond. So the second step is, once you identify the number of sigma bond, you can mention beryllium has 2 sigma bond. If you have 2 sigma bond, the type of hybridization is SP, because S sama dengan 1, P sama dengan 1, the total is 2. Okay, alright. So this is the second step. The third step is we will focus on the central atom. Okay, apa yang kita akan buat? We focus on the valence electron for beryllium. We did beryllium ground state. So we have this. One, two. Alright. So the concept of hybridization or orbital overlapping, for an electron to undergo overlapping, the electron must be half filled in an orbital. So in this case, this orbital is fully filled. So it cannot overlap with another atom. How to make it available for overlapping is we have to excite one of the electron to the empty orbital. I show the 2p orbital just to show you that is the empty orbital available for excited state. So the second one is beryllium excited state. We will have this once the electron is excited. So you have one here and one here. Now you have 2 available orbital for overlapping. And the third one is hybridization. We blend these 2 together and it will become a new set of orbital with the same energy level, which is sp, that occupy 1 electron each. Right? So this step is very important for the central atom. Okay, this is one whole set. It's begin with the ground state, excited state, and the hybridization. Okay, so this is for the central atom. What about the terminal atom? So in this case, our terminal atom is chlorine. Chlorine is group 17 that have 7 valence electron, and it come from period 3, I think. So chlorine ground state. So chlorine tak perlu excite. Okay, we only focus on the central atom or any central atom with a multiple bond. Later we will look at this multiple bond. 3s, 3p. Okay, if we look at chlorine, we have 3 full ataupun full orbital lah, and we only have 1 available orbital for overlapping because it only have 1 electron. So how to make it, the next step is we will focus on the drawing part. Kita kena buat SP. SP, the shape is linear. So kita kena buat 1. This is beryllium. 2. This one represent orbital SP. This one also represent orbital SP. Each loop, this one bring 1 electron and this one also bring another 1 electron. Okay, it will overlap with chlorine, and chlorine have 3p orbital. The shape of p orbital is dumbbell. It is different, so you have to draw the dumbbell shape. This one, the orbital is 3p that represent chlorine atom, and don't forget to label it is a sigma bond because it is a single bond. Another one is we have this is 3p orbital that bring 1 electron in an opposite direction, and it will form a sigma bond, and this is represent chlorine atom. So this is a complete set of orbital overlapping. You must label the orbital, the atom and the sigma bond together with the orbital at the terminal atom. Right? So this is, the shape is linear and the hybridization is SP. Meaning that it is tally with our hybridization and our Lewis structure. Right? Okay, so that's all for SP orbital. We will look at the second video that explain SP2 orbital. Okay, thank you very much.